Another thing you might be wondering is, what if the curve is below the x-axis? Because so far we've been talking about and working with examples that are exclusively above the x-axis, like for example graphs that look like this or graphs that look like this, and finding segments of areas which we sometimes say are bound by the x-axis, bound above by the function and below by the x-axis, sort of like that. But what if the function is below the x-axis? What happens? Well, basically everything works exactly the same. The difference is, if we're talking about the area underneath the x-axis, it will still be connected to, it won't be below the curve, it will actually be above the curve. But one of the things is that an integral always calculates the area connected to the x-axis in such a way. But if the area is below, what will happen is the integral will measure that area as a negative amount instead of a positive amount. It's kind of like area above the curve, area above the x-axis but below the curve is signified by positive sign, where area underneath the x-axis but above the curve is exactly what an integral will do. So let's say, let's actually just look at example 5. But, to fill in the blank here in our note page, what happens if the curve is underneath the x-axis? What we'll get is negative area, which is kind of strange. Usually in geometry, you don't ever think about area as negative. It's like a positive amount strictly. But it's because it's positional. And area, this is just something to know, is area above the x-axis is treated as positive, whereas area underneath the x-axis is treated as negative. And if you have a combination of area going both below and above the x-axis, they'll kind of counteract each other, as part of it is negative and part of it is positive. So you can have certain curves where the area is actually 0 underneath the curve over a certain interval, because those areas kind of cancel each other out in that sort of a way. But let's take a peek at an example. It says to calculate the area underneath y is equal to x squared over from 0 to 4. So basically what that's saying is we have our x squared curve, and we want to know what's the area from 0 to 4. And as we know by the fundamental theorem of calculus, we can do this by definite integral, by solving an antiderivative function. So that would be x cubed over 3. Take the antiderivative and plug in 0 to 4. And of course, 0 would give me 0. 4 would give me 4 to the third power, which is 64 divided by 3. So the exact area under the curve should be 64 over 3 minus 0, which is 64 over 3, to get a precise area under the curve. And if we are imagining what it looks like, we have a parabola, x squared. And what we've just found is, well, what's the area bound by the x-axis and the curve in between those two curves, like so. And we'll look something like that. But let's say we took the exact same problem, and instead of dealing with y equal to x squared, let's say we inverted or reflected that parabola, put it upside down, and we were looking at the graph of y is equal to negative x squared from 0 to 4. Well, since it's negative, of course, it would be beneath the x-axis, and it would be exactly the same pattern, but below instead. And so what we should expect here is to get a negative amount of area, because this curve is underneath the x-axis. And if we were to do the math, again, you don't have to change anything about how you approach your mathematics. You just plug in the function and integrate, with respect to x. And the power rule will still work. Remember that even a negative can be passed through the integral symbol, because it's a constant multiplier, right? And, by one of the properties from integration from last week, multipliers or numbers can pass right through. But you could even just leave it in there. And again, the antiderivative of x squared is x cubed over 3, and that negative will just not affect the antiderivative. And I need my boundaries of integration, and I need to plug it in, but I'm going to get the same exact answer, but it will be negative 64 over 3, because it will be the same graph, just flipped over, and we get a symmetric answer. But anyways, you should, sometimes you will get negative answers for area, and that should be expected when we're dealing with parts underneath the curve instead.